Hi, now I'm going to use the quantum phaser to demonstrate the nulling of long wave. This is in particular an NDB over at Denver International Airport. The NDB AP, it's very strong as you can see. The airport's about 30 miles away as the crow flies off the top of my head. Anyway, I'm using two low noise verticals that are nearly identical. One is 27 feet tall, about 5 feet off the ground on a tripod, and the other is about 30 feet long, about 4 feet off the ground up in a pine tree. And both of these are using 14 gauge wire. So they're spaced about 85 feet or so apart. And I'm going to use the quantum phaser to null the signal. Now if you look at the carrier here, you can see, it's probably hard to see, but it's at about minus 22 decibels with the sidebands where all the signal is coming from. Down here about the noise level is minus 60 decibels. Now these are just arbitrary numbers. But what I'm going to do is I'm going to put the phaser in. Right now the phaser is out, and I'm only using one antenna. And when I put the phaser in, the signal gets nulled quite a bit. It goes from about 22 decibels, minus 22 decibels, down to about minus 45 decibels. So that's roughly 23 decibels of nulling with just 85-foot spaced, similar, nearly identical antennas, spaced about 85 feet apart, with the quantum phaser. Next, I'll do it. This one here, this example here is using a RTL 2832 dongle, just one of those cheap $15 dongles with a hammered up Upconverter in order to allow me to receive it in long wave, and it's being put through here. The sensitivity on the dongle is not as good as the Rycom I'll use, the analog receiver, but you can see right here on the screen the nulling of the signal quite a bit, and the background noise doesn't go down nearly as much. But here's it with the phasers in. And now the phaser's out. You can see the background noise doesn't go up too much, and there's some other signals. They may be intermod from local radio stations or something like that. Even with a low pass filter on this, filtering below 520 kilohertz, I still get some intermod. But as you can see, here's the AP NDB. I'll let it go through a couple cycles, coming in loud and clear with the phaser out. And now with the phaser in, this is also, by the way, one of the strongest NDBs in my area here, so it's a real powerhouse, and you'll see that more illustrated on the analog one, which it actually blows the meter to pegging. Phaser out. And phaser in. And here I'm going to do an analog demonstration of the nulling capabilities of the quantum phaser at low frequencies. This is using the same two low noise vertical antennas spaced about 85 feet apart. One's a 27-foot wire antenna on a 5-foot tripod, and the other one's a 30-foot long wire antenna up in a pine tree. I'm using the Rycom R1307A GR long wave receiver. And right now we're receiving, the main signal is AP260 NDB at Denver International Airport, which is about 41 kilometers away. And also we're receiving, you can see under here, under the sideband, you can see BF in Scottsbluff, Nebraska, which is about 264 kilometers away. It's about 3 o'clock in the afternoon here in Colorado. 2:30 here actually in the afternoon in Colorado, so we're not getting much skywave, it's mostly ground wave. So anyway, right now the phaser is out position. You can see the signal coming in fairly strongly. I don't know if you can see the decibel gauge over here on the Rycom, but it's actually pegged. I actually have it I have it on full signal right now. If I attenuate it 10 decibels, it goes down to 0 on here. But right now I want to keep it pegged for the demonstration purposes. You can see where I turned it down right there. So right now, AP260 at Denver International Airport, phaser's out. and the phaser's in. If you look on the meter here, we're just a hair above negative 20 decibels, which means it went from pegged, which is, in this case the upper end is 2 decibels, plus 2 decibels, down to roughly minus 19, minus 20 decibels. So it's phased it out more than 20 decibels in total. You can still see the AP signal. You can also see the sidebands. The Nebraska one, unfortunately, has disappeared. So, although the phaser does work to null out a strong signal, it also is not sharp enough to null out something that you might be interested underneath. Now, normally at nighttime when I'm looking at this, I look at this a wider bandwidth when I'm DXing NDBs, and I can see multiple ones under 260, which of course blows out a lot of it, makes it a little bit more difficult. So although we can null out a strong signal with the phaser, in this case AP260, I don't know how useful a phaser would be for NDB DXing, especially if you look at a narrow bandwidth. As you can see, when the phaser's in, it also it also nulls out anything. So the null is quite wide as far as the number of kilohertz, and I don't know if wider spacing would help, but you can null out a long wave signal at least as far down as 260 kilohertz. I don't know how much it'll help in the broadcast band. I assume it would help a little bit. We'll have to try that at night sometime. Also, you can hear a little bit of intermod that makes it past my low pass filter when I'm giving full signal here. Anyway, that's nulling out long wave with the quantum phaser. The phaser right now is out, one antenna being used, and the phaser in with both antennas phasing their signal. And that's it. Here's another quick example of nulling out long wave with the quantum phaser. Here's NDB, it's a 400 FN, and this is in Fort Collins, Colorado. It's a little bit farther than the one in DAA, but here's it with the phaser out, using only one antenna. Decibel reading is about minus 27, minus 28 for the carrier. When I pop the phaser in, it goes down to about minus 42, so minus 27 to minus 42. So what's that, about 15 decibels or so? So it's nulling out some. Maybe not have tweaked it as well as I did with the 260, but anyway, you can see that's nulling it out at 400 kilohertz. Here's the phaser out. See some of the sidebands popping up as well, way over here. Like it has a spur. And then with the phaser nulling,